Okay, guys, we'll continue now. So,
integration of improper.
Yep.
Improper.
Hey, guys, come on. Hey, come on. So, integration of improper partial fractions. Mohammed S. Ere. Daniel, come on. I want to start. Integration of improper partial fractions. Whoops, ran out of space. I'll turn the light off. Okay. Let's have a look here. Come on, please. Now, this one here is very, very similar to the last one, but it's much more common in the exam. So I think what I'll do...
Is it not difficult?
No, it's not. Just the difficult part was trying to find the A, B, and the C.
You turn it into a proper.
Yeah.
Then you just do the
Yeah, as normal. I think. Yeah. Let's have a look at some of them. So let's have a look. Let's see.
Number 5 puts an A.
I want to pick one a little bit more difficult than what we just did.
Q. Random picture. S.
Hang on.
T. Not Y. C. Y. Q. Y.
I'll do these three. So first one.
First Q?
No, G, H, and I, if they're the same. Okay, so first example. 54x4 minus 345x cubed minus 1394x squared minus 955x minus 320 all over. 27x cubed minus 186x squared minus 493, that should really say x, minus 180 dx. So the first thing we do is to split it, and we had the lesson on that, and I did an example in the tutorial as well. So you'd have to do your long division and then make it a proper partial fraction. So anyways, after you split it, and in fact this is a question you've done already, you'll end up with 1 plus 2x minus 5 over 3x plus 5 plus 4 over 9x plus 4 minus 7 over x minus 9 dx. So you can see nicely that you've actually done all of the difficult work already from going from here to here, because these three are easy to do. I know actually I've been saying at this point let u equal to this, let u equal to this, and let u equal to this, but in fact I think these are in the formula book, aren't they, as like a over bx plus c? Yeah, so you could actually just go direct to the answer. This would be x. This would be x squared. This one here from the formula book is minus 5 over 3 log 3x plus 5 plus 4 over 9 log 9x plus 4 minus 7 log x minus 9 plus the c, of course. Okay. What I'll do as well, I'll put in some limits. So actually, this is something which students are actually a little bit weak at sometimes in the exam, so I'll let you try it first and then I'll do it on the board. I'm going to put in limits, let's see, I'll try and put in easy ones. 0 should be okay, and no, I don't want to have pi in it because there's no tan, so I want to pick something like, hold on, please, just give me 1 minute to think. Yes, 0 and 1 go too fine. So I want you to give me the exact answer here, and I'll do it in a moment, but try and simplify this as much as possible. So we have 0 and 1 as the limits now, 0 and 1, 0 and 1. See what you can get. I'll give you a couple of minutes.
If you put the 0 to the last one,
This I know, but it actually turns out not to be a problem. You can actually deal with that. So don't use, see this is the thing, don't use your calculator because you might feel like you have to stop early. Just try using algebra as much as you can to simplify it. Okay, just 1 more minute, see how far you can get to simplifying. Okay, so let's have a look here. So if I put in 1 first, I would get 1 plus 1, which is 2, minus 5 over 3 log 8, plus 4 over 9 log 13, minus 7 log minus 9, which looks like a problem. In fact, it won't be later. Minus, and then I put in 0, 0, 0, minus 5 over 3, minus where?
9, 8.
Minus 7 log minus 8.
Yeah, right?
Oh, this is not 9?
1 minus 9.
Yeah.
Oh, sorry, I'm putting 1 first, not 0. Thank you. I was going to the next step. So this is minus 8, yes. Minus 5 over 3 log 5 plus 4 over 9 log 4 minus 7 log minus 9. Okay. So we get 2 minus 5 over 3 log 8 plus 4 over 9 log 13 minus 7 log minus 8 plus 5 over 3 log 5 minus 4 over 9 log 4 plus 7 log minus 9. Now, I can clean this up a bit more because I can say this is 2 minus log 8 power 5 over 3 plus log 13 power 4 over 9. Now, you can bring the minus up, but I don't think I will. I'll just change this minus log minus 8 power 7 plus log 5 over 3 minus log 4 over 9 plus log minus 9 was here, power 7. Now we can use our first and second rule of logs. When we subtract, we divide, and when we add, we multiply. So the 2 stays there, but I can change this into 2 minus log, and now I need big brackets here. So the first one is a minus, so it goes into the denominator. The second one is a plus, so it's multiplying, so it goes in the numerator. This one is a minus, so it goes into the denominator. This one is a plus, so it goes in the numerator. This one here is a minus, so it goes in the denominator. And this one here is a plus, so it goes in the numerator. And what I've done there in one step is I used the first and second rule of logs, 5 times. So I used the first and second rule of logs 5 times in a row, and it will simplify down into that. But now you can see the great thing is those minus logs aren't a problem anymore because that minus will cancel with that minus. And I can actually clean this 8 and 4 up as well. This 8 can be cleaned up. The 9 I can do something with. The 5 and the 13 I can't. So I have 2 minus log 13 power 4 over 9, 5 power 5 over 3. This will be 3 power 14. This will be 2 power 5. This one here is 2 power 21, and this one here is 2 power 8 over 9. So I'm using my lesson from semester 1 on powers, rules of powers now. Okay, so you can see there's lots of 2's here. 13 power 4 over 9. 5 power 5 over 3, 3 power 14, and then 2 power minus 5 minus 21 minus 8 over 9. Can someone just give me this power here, please? These 3?
Minus 1 rule over 9.
242 over 9 times 3 power 14 times 5 power 5 over 3 times 13 power 4 over 9. That is the answer, as simplified as I can make it. I can't make it any smaller. There's nothing left to cancel, there's nothing left to add or subtract together. This is the answer then. Yes?
What did you do from step 1 to step 2?
Step 1 to 2. I just changed my 8s into 2 cubes and my 9s into 3 squares. See, this is the thing, people ask me, semester 2 exam does not have semester 1 topics on it. I'm like, well, no it doesn't, but you can see here it builds on it because we did the rules of powers and logs in semester 1. So I think this is part of the reason that students find this difficult in the exam too, because they deliberately forget what they've learned in semester 1 somehow. Okay, let's have a look at another example. Yeah, let's have a look at maybe H. Possibly H, possibly. No, maybe not H. Let me think. Maybe then. Yeah. Okay. J, I think might be a good one to do. Yeah. J. Yeah. And I'll add to it again. Okay, so what I'll do differently here is I will find the A, B and C, the part that I've been skipping, just as a little bit of revision. So I want to do this question fully, so you can see, at least once, how long and how much you have to do in section B for a 10-mark question. Okay, so first step, we look at this here, and we try to factorize the denominator. So what are the factors in the bottom? It has factors.
Are you doing it fully?
Yes.
X plus 1 and 2x plus 1.
X plus 1 and
2x plus 9.
2x plus 9? Yes. So that's good. We have factors here. And we don't need to do any long division to get any of the factors as well. We have both factors for the quadratic. So for improper, we have to divide first. So let's do our long division. Okay, so firstly I would need 3x, that would make 6x cubed plus 33x, yeah that's right, plus 27 x squared and an x here. Okay. Leaving me with 2x squared plus x plus 2, just close, plus 1. 2x squared plus 11x plus 9. I subtract and I'm left with minus 10x.
How did you get x when you subtract 58 from 27?
58? Uh-oh, something's gone wrong.
58.
58?
38.
58, 37.
Yes. How did I get x? Oh, I must have just looked here and didn't bother to look 1 centimetre to the left to see that they were different numbers. So this should be 11x plus 2. So that's actually nicer, because if I put plus 1 here, I get 2x squared plus 11x plus 9, so minus 7. Okay, so what I'll do, here I'm just going to erase this piece and put in the 2 factors. So that is x plus 1 and 2x plus 9. And then on the top, now that we have the long division done, we can say that this piece here is equal to this multiply this plus the remainder of minus 7. And I can put that in on the top, so rather than writing it again, I'll just remove this. You can write it again or just put it on top, but just so I don't run out of space, make it easier for me, I'll just write it on the top here by removing that one. So on the top we have now 2x squared plus 11x plus 9 brackets 3x plus 1, and then the remainder is minus 7. Okay, now what I do is I separate this into 2 pieces. So I think, yes, I'll just, can I remove this long division here? Yes? Or what? I'll leave it, I'll just write it in underneath here. So we have 2x squared plus 11x plus 9 times 3x plus 11 over x plus 1 times 2x plus 9 minus 7 over the same thing, x plus 1, 2x plus 9. And I won't bother writing the integration in just yet, but it's still integrated, of course. Yes?
Isn't it 3x plus 1?
Yeah, sorry, it's my handwriting here. That's a 1 there. Okay, and something cancels in the first fraction. What cancels in the first fraction? The 2x squared plus 11x plus 9 cancels with these 2. So I'm just left with 3x plus 1. So now I have a proper partial fraction to deal with here. So if I go to the side here and just write down our new problem, we're looking at 3x plus 1 minus 7 over x plus 1, 2x plus 9. And in fact I can go to the side again because I don't care about this piece at the front, I just want the fraction part. So I'm looking at this now. Now, again, just like in the tutorial, I'll skip a couple of steps because we know what's happening here. We say that this is equal to a over x plus 1 and then b over 2x plus 9. Then we multiply by the x plus 1 and the 2x plus 9 and things cancel. So after that you should be left with minus 7 equals a 2x plus 9 plus b x plus 1. I've skipped a couple of steps. Steps that are the same every time, and we've done them a few times. There's nothing weird happening here as well. There's no repeated factors or anything strange like that. It's very, very straightforward. So if I choose x equals minus 9 over 2, I get minus 7 equals b times minus 9 over 2 plus 1. What's that, please? Can someone just... Minus 7 over 2. So I get b equals 2. And then if I say let x equal minus 1, I get minus 7 equals a times 7. So a equals minus 1. Okay, so that's great. We have our A and our B. So we can go back to the question on the left now. Well, I'll just give you another minute here. Yep. So, going back here, we'll make space by removing this because they cancelled. Okay, and then this. Okay. It's probably not the quickest way to do it. Alright. Now, we have the A and the B here, so this is 3x plus 1 minus, and what did we say the A was? So it would be minus bracket minus 1 over x plus 1, and then the B was 2? So plus 2 over 2x plus 9. Okay, and let's not forget this still has to get a 0 to 1 dx. Okay, so just write that part down. Okay, so this is 0 to 1, 3x plus 1 plus 1 over x plus 1 minus 2 over 2x plus 9. You can use the formula book here and you will get 3x squared over 2 plus x plus log x plus 1 minus log 2x plus 9. And we have 0 and 1 to go in. So if I put in 1 first, I'll get 3 over 2 plus 1 plus log 2 minus log 7. And then if I put in 0 next, I get 0, 0, and log 1 is 0, yeah? No, this is actually right, because what you can't see here is it would be 2 over 2. This 2 being this 2 here, and this 2 here coming from this one here. No, don't worry, that is right. If you look at the formula book for it, you'll see it. But you're right, there is a 2 here, and there's actually a 2 here, they both cancel. Another way to see it is if you make u equal to 2x plus 9, what will happen is that the u dx makes a 2, which will cancel the 2 up the top as well. So no, that part is right, don't worry.
V over 2.
We are talking about this, aren't we?
The sign.
The minus? I'm not sure what the problem is. The A and the B. Alright, sorry. It's minus 1 and 2, wasn't it?
The minus sign you're adding
Into the 7? Oh, I took this, I see, okay, thank you. I put the minus into the 7 already, thank you. So actually that there should be a plus here. So it just means the signs need to be switched around. So that one there was a plus, is now a minus, and that's a plus. That was a plus, it's now a minus, and that's a plus. Okay, so that means here, when I put in 1, I get 3 over 2 plus 1, so that's a minus now. And this is a plus. Okay, now I put in 0, I get 0, 0, minus, oh well that's still 0, log 1 is 0, so actually I'm just left with this, log 9. Okay, so I have 3 over 2 plus 1, so what's that, 5 over 2, 5 over 2 minus log 2 plus log 7 minus log 9. That's 5 over 2, and then this would be minus log 2 plus log 7 over 9, which is 5 over 2 plus log 7 over 2 multiply 9, because there's another minus log, so we have to divide again. And that's it then. The answer is 5 over 2 plus log 7 over 18. That's the exact answer. That's very, very typical for the exam. I don't know, what's that, about 10 minutes to do that for 10 marks? It's okay. I don't know, was it about 10 minutes for that? What?
The question in the exam, are they harder than this?
Sometimes they can be a little bit harder than this, because this one here had only log in it, but sometimes you get tan inverse in it. In fact, it's more, usually you get tan inverse in it. So this would be, I'd say, medium difficulty in the exam. It can be a little more difficult, sometimes it could be a little easier. Yeah.
7, log 7 is log 11.
Scroll up.
That's 2x plus 9.
Where?
9 plus.
This here.
No.
This here.
Yeah.
Thank you. That should be 11. Did I do the thing where I put 0 in? All right. That should be 11. 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 You're ready. Joshua, focus please. What are you doing there? Look like you're messing. Put your foot down front, please. Alright, yeah, for a few minutes try one of these. You should be able to do one of them before we go, okay? So try one of the integration of improper partial fractions. And I think it'll be very good practice and revision if you try to do the part about finding the A, B and C as well, as a bit of revision, okay? So, for example, what I'd like people to do, I should pick one where it is different. I just did J, didn't I? And I don't think I did I. What was my other example I did?
G and V.
No, it's F.
Well, I didn't do I anyway, the one that has 21 in it. So can everybody try I on 38? That will do nicely. Yeah, well, you can also think about Google, but you'll see in Google there is a formula for integrating fractions, right? So
Something green.
أنا في الأصل